Welcome to this short video on partial fractions, where we're looking at a particular problem that occurs when the denominator contains a repeated factor. Okay, so let's have a look at this example here. We could easily see that f of x can be written as with 2x minus 1 on the numerator. Okay. And on the denominator, we have x plus 3 all squared, a perfect square. Okay, so we'll just write it in full as x plus 3 times x plus 3. Okay. Now, normally we would then proceed with those two factors underneath, which happen to be the same as each other. Okay, because what we're going to do is we're going to set that equal to a over x plus 3, okay, plus b over x plus 3. Okay, they would be our partial fractions, you see. This is what we would normally do with a pair of factors that were different on the bottom there. And we're just going to do the same thing and see what happens. Okay, now it seems okay so far. So we now process it in the normal way. So what I would do is I would aim to change the denominators of these to a common denominator, and the lowest common denominator of all three of these would be x plus 3, x plus 3. So what I would have to do is multiply each of these by x plus 3 over x plus 3, and then I would have a common denominator. So that would lead me on to this, wouldn't it? It would be on the next stage, I would have a times x plus 3 plus b times x plus 3. Okay, and that would equal 2x minus 1, because what I would have had was a common denominator below that, and that of x plus 3, x plus 3. So I've just taken that out. Okay, so we process it further, and we would say that that would give us that ax plus 3a, okay, plus bx plus 3b would equal 2x minus 1. And then we would say, okay, let's equate coefficients, but first gather like terms together. So we would have ax, or a plus bx, right? So a plus b times x, that's coming from this term and this term, plus 3a plus b as the constant, if you like, the number, would equal 2x minus 1. Okay, and so equating coefficients, we would say that a plus b equals 2. Okay, so let's just write that here. A plus b equals 2. So far it seems okay. And then we have 3a plus b equals negative 1. Now, hopefully, at this point, there seems to be a problem with that. Because if a plus b is 2, then 3 lots of 2 would be 6, not minus 1. So it just simply doesn't work. So what do we do? So this doesn't work, and it doesn't follow what we expect to happen. We do this instead. I'll just put a partition down there, okay, and we'll switch to a different color, and we'll do it in a different way that will work, and then you'll see. So instead, let's do this. we'll say let f of x equal not a over x plus 3, but this. We'll let 2x minus 1 over x plus 3 x plus 3. Okay, so we're starting off with the same original fraction, but this time we're going to make it equal a over x plus 3. Okay, but instead of putting b over x plus 3, we're going to put b over x plus 3 squared. Okay, so we're changing one of the denominators by squaring the repeated factor. Okay, now it changes everything and it works. This is what happens. You see, we still have a common denominator of x plus 3 squared. It's there, and it also now appears here. So this time, when we come to process it, we would have that a would still need to be times by x plus 3, okay, because we would be putting x plus 3 over x plus 3 there, you see, plus b, which is already over x plus 3 all squared, would equal 2x minus 1. Okay, do the same thing, we just expand it all out. Ax plus 3a plus b equals 2x minus 1. Okay, now if I just put a bracket round here, that kind of highlights the constant. Okay, and we therefore say that ax must be 2x, therefore a is 2. Okay, so from here I can say that a equals 2. Okay, and I can say that 3a, 3 times 2, okay, plus b equals negative 1, okay, which means that b equals negative 1, negative 6, so b equals negative 7. And now I found my constants a and b without any problem. Okay, so I go to my original statement and say that f of x in partial fractions can be written as, now make sure you put the right thing over the right factor, so it was a was the minus, was the 2 over x plus 3, so it's 2 over x plus 3, okay, as the first fraction, and the second fraction was equal to, well, it's negative 7, so you don't need to put a plus sign there, you can put minus 7 over x plus 3 squared. Okay, x plus 3 all squared. Okay, and that is the partial fraction breakdown for our function. And that's how you deal with any repeated root, any repeated factor at the bottom. Okay, so you keep one of them as it is and you square the other one, and that will solve the problem in any of these partial fraction questions. Okay, I hope that's helpful and you can see a potential problem that you can avoid by following the steps shown here. Okay.